Hi, this video is about header files. In this video, we will get to know how to split code into multiple files uh, with the extension .h and .c. Also, the use of the include directive. Mm, we will get to know how to include header files from uh, subfolders in the folder of our project, how to use header guards and the Extern keyword in order to protect and make all of the use of our header files work without any issues. Okay, we already seen that we have a .c file which basically contains the main function, but we have also have used header files from the C standard library by using the include directive. So we basically familiar with statements include and stdio.h within these two arrows. It basically means that we are using a header file which contains some definition or declaration of functions. So remember, for instance, whenever we use the printf function, this is a pre-designed function. It's not ours. We are just using it, but we have to use the stdio.h file in order to use it. So basically, we have used already header files, but now we are going to see that we have also we are able to create or customize files, .h files. That is, we will try to define and create functions that we are going to specify in different files, and we are going to call them from our main function or our main file .c by using the include directive. So basically, whenever we create our own header files, it is known as user-defined header files or source files, and we will include them by changing the syntaxes a little bit. So we will use also the include directive, but now we are going to use quotation marks to specify that it is a header file that is user defined, not the standard C library. And it basically implies that it's going to be fetched or it's going to be searched in a different directory. So we will use double quotation marks whenever we define our own header files with our own function with our with our functions. Okay, and this one is for standard C library functions. So basically, what I mean here is that whenever we use this header file inclusion from the standard library with these arrows instead of the double quotation, our compiler is going to work like this. Since I am using the dev C++ compiler, it's going to search in the root folder, and here this architecture 32 and 64 bits, and the include directory, and it's going to find here, for instance, the stdio.h file, which is basically in all of the folders of the installer of my compiler. Okay, so basically somewhere here we have the stdio.h file. Here we have this one is the header file, the .h file for IOH. As you can see here, we have defined some variables and some functions and operations in the low level that communicate with Windows operating system to deploy the terminal window and all the stuff that we do in our computer. We don't have to know these low level details. I just wanted to show you that this is when we use this arrow notation for the header file, the .h header file, it means that it's going to be searched in this folder of all of the files of your compiler, okay? But whenever we use the double quotation marks, instead, uh, it will follow the same location in our file system. So, for instance, let's say that I have my project here in this folder, header file, and I am including the rest of the code in a different header file. So I should be including the header file in the same folder. So if I have double quotation, it will look, okay, this is where the main function is in this file. This is my main file, source file. So where do I find the .h header file? I will have, it will start searching if I use double quotation in the same folder, okay? All right, here's the example code. I'm going to run this program. So let's have a look at this. Here we have a printf message, and we are printing the result of this function call. So here basically I mean to add these two values and return the result an integer, okay? So basically, since we are going to learn how to split our code into multiple files, we will use a header file that will include the definition of this function. So this add function will not be defined here in this .c file, which contains the main function, but instead it will be in another file. So, okay, just remember that we will have to use all the files of our project in the same folder, okay? So, okay, now I'm going to use the header file. I will create a new source file, and I'm going to define now my add function. So it will return an integer. Its name is add, and it will take two arguments, two integers. And now in the body of the function we will use, I will create an integer c, and it will be the result of the addition between a and b. And I will return c, which is, the addition of these two arguments. And now I will save the file. I will use here in type of file header files, and I will give it a descriptive name. For instance, I will use add.h. Well, actually, I don't have to specify the .h because it already will format this file with the .h extension. Okay, so I will just name it add, and we'll save it. I am overwriting this file, so no worries. Okay, now remember that when I haven't defined anything in C programming language, I will have to do some prior reference before calling this function, or otherwise the compiler will find an error because it doesn't know what add is. So for that purpose, we will use the include directive to include the file that contains the definition of that function. Remember that it is not a standard C header file, so we won't use these arrows here, but instead we will use the quotation Okay, quotation marks. So basically, remember that we called this file add.h. Okay, I saved the changes and let's hit run now. Okay, excuse me, I have some errors here. I will erase this from a previous code that I did. Okay, let's hit run. And here we are. The addition is 8. 3 plus 5. So basically, what we've learned here is that we have to use double quotation marks to include the header file inside the same folder location. But there's one more thing I have to show you here, and it is that the rule of thumb is that we have to use a .h file for just the declaration of functions or the declaration of a variable if we're using variables that are defined in a different file. But we should have we should specify the definition of the function, that is the body of the function or the entire function, in a different file, which should be a .c extension. Okay, so basically what I mean is that I will have to create a different file, and in the .h file I will leave just um, the declaration of the function, as you can see here, the function prototype. And in another file, I will include the definition of the function, that is the entire function with its body. Okay. Um, and I will save this, which is the entire definition of the function, as a source file, .c file. Okay. And I will use the same name that I gave to the .h file, which is add, because it contains the add functionality. So I will click save in the same directory, and basically what we have here, um, the declaration of the function in .hc file and the definition of the function in .c file. Okay. Okay, now I will have to make some few changes. I will go to Tools menu, Compiler Options, and then in the Linkers section, I will add the following, in the part that reads add the following commands when calling the linker. And as you can see here, we have some strange comments. But now I will have to add the name of the C file in which the definition of the function is. That is because I am including the .h file here, but remember that my function is in the add.c file. So I will have to specify add.c because it's the C file where the rest of my code is, okay, in the linker section. Now I will hit compile and run. Okay, now it's working. I guess I hadn't saved changes here or here, so I click save changes in both, and now it's working. So basically, remember, we will have to use the .h extension just for the declarations of functions and variables, and the definitions and the function bodies will be in the .c file. Okay. All right. Now let's here's one more thing I want to show you. Whenever working with header files in your the same folder directory, I can also uh, perform the following. I can create a new folder. Let's name it folder, and then I'm going to save this. I am going to move this .h file in the folder subdirectory. Okay. Uh, this is because I am supposed to want to, I don't know, maybe associate or save organize the header files in different subfolders. Okay, inside the folder of my project. So since I am adding here a folder in which I will have to look for this .h file, I will have to specify the route, the path in this fashion. So I will use here folder, which is the folder containing the .h file inside um, the folder of my project. And now let's hit compile and run. Okay, it's working again. There are some other ways uh, in which you will use header files that aren't inside your folder, the folder of your project, but instead they could be, I don't know, in a different folder when you're using third-party software. So there are ways on the compiler options, your IDE, on directories or include directories. Okay, so I won't dig deeper in this topic, but it is something you can do because you don't always have to place all the header files inside your project folder, but instead you will use just your main source file, which contains the main function, but you will link or you will specify in the directory configurations of of this project where the files could be. Okay. All right, now I will show you in the next topic um, something called header guards or include guards, which are used with the header files to avoid some basically the redefinition of functions or variables. So I will show you with an example. Here we have the use in our program of a structure which is named as student. This is basically an array of characters, an integer, and a double uh, to specify data of a student. So here we have the name, the age, and the average. And here I am creating a student variable named Carl. So basically here I initialize the structure and then I use this function that will print in the console screen data of this variable Carl, which is this structure, okay, with these values here. Okay, so basically, since we are splitting code into multiple files, we will use header files and C files, okay, to specify uh, this operation, this function, and this data type that we created. So okay, I will use .h file. I will name it student.h, and I will define. I will declare what the student type is. So basically, I will use type.def for this structure, and here we have an array of characters, an integer, and a double, and I will name it student. Okay. So now you know what I have to do. I will have to include double quotation because it is a user defined file uh, in the same folder student.h, and I will save changes. Now my program or the compiler will know what I mean by student type, okay? Because I am including here the student age, which contains the declaration of what the student type is. What I'm missing now, uh, this function, okay? Now show student. So remember, we will have to use a .h file, show student.h, for to specify the function prototype or declaration, okay? So basically it's a void, returning a void. It Here you have the name, and then you have the arguments list, which is basically a student type. It receives a student variable, which is that structure, and it returns void, okay? Okay, so now we have the student.h. Remember to include this one also. Sorry, student.h is what I mean. Okay, now we have the prototype here. But we are missing the definition of the function, okay? So basically what it will do is take the student variable and it will print in the console all of its members. So I named this variable received as an argument as st. So basically I will access the member of this structure by using this, the dot access, and it will print the age, the name, and the average. And here we have the printf with the appropriate format specifier. Okay, so it seems like we are done here. So I will save changes and hit. Oh, so remember something. Here in Tools and Compiler Options, I will have to include in the linker section, add the following comments when calling the linker, the .c file that contains my code, which is the function show student, which is in the file named show student.c. So I will include this one here so we don't have any problems, and check this box. Okay, so remember that it will compile that part of my C file here, which is my function. So this is why I have to include it in the linker, because this program is incomplete because it needs the executable part of the show student function, which is here. So it's basically compiling the show student.c on the main C file and then merging or linking them together. Okay, so this is why I'm basically telling there. Now we'll hit run, and we will have some errors. So as you can see here in the show student.c file says it reads unknown type name student. What does it mean? Okay, I specified here this is the argument that it will take student variable type, but I haven't told what the student variable is. So for that purpose I will have to, include the student.h file. So I will have to use include the student.h file also in this show student.c, because it will need also the definition of student to know what it's dealing with. Okay, and this is basically this information is here. So this is why I have to include. Now bear in mind that I'm including the student.h here and here because all of them need the definition of that function. Also, I could have also include the stdio.h. Remember that we are using the printf, and all of this space was blanked, so I haven't made any reference to the printf nor the student variable. Okay, so I will have to complete with the stdio.h because I'm using here the printf function. Okay, remember this is the standard function, so we will use these arrows here, and for this one the quotation marks. Okay, I save changes, and let's say here for show student.h I will have to also define or make the reference to what the student type or variable is. Okay, so we don't have any errors. But now bear in mind that I am including the student.h file in all of these files. Okay, now let's hit compile and run, and we will have this flag errors here that says conflicting types for student type. Okay, previous declaration of student was here. Okay, so basically what it's happening here is that, okay, remember that the purposes of directive include basically copies the content of this text in this file. So student.h will copy this definition of the student type. Okay, okay, sorry. So basically you will copy this here, and then the next directive says include include the show student.h. Okay, I'm going to go here, student.h, show student.h, and what's the first directive here? Include student.h. So it will include this one for the second time. Okay, so it will do this basically. So now we have an error of a redefinition because I already defined this student type previously. Okay, so this is because I am including uh, a file for the first time. Now I'm including a file that also includes this file, the same file itself. So it will be duplicating the definition for that uh, variable or data type that I created. It could be also a variable or something else that it's repeated, duplicated. Okay, so in order to avoid these errors, we will use the uh, header guard, okay, or include guards. Basically, we will use this purposes or directives in the header file that it's being duplicated, which is student.h. We use if and def, and here we place a text that basically should be related to this header file. So I'm going to use, remember that a macro uses capital letters, so I will use student underscore h. The second line should be define and use the same text that you used previously. Okay, and at the end of the file, the contents of your file, we will use endif. So basically that is a header guard, and it will basically do conditional compilation of your code. So for the first time it will start doing okay, basically it says if not defined, then define this. Okay, so remember that we use the define directive. We basically tell the compiler to replace this text here with this value. So basically, if I use 3, it will be replaced with this value, numeric value 3, okay, instead of the text. So when I use here uh, define student, basically equals all of this content. So basically what I am saying here is if student.h is all this content wasn't defined or wasn't included for the first haven't been included previously, then include it in this main file. Okay, but However, if it was already defined, don't do it again. So it will guarantee that it is not included twice, okay, to avoid redefinition of these variables or data types or functions wherever I have in my header file. So basically, this is what we have here. If it hasn't been included previously, if not defined, then define it, include it. Otherwise, don't include it. So the body will be, sorry, the body will be for the header guard. If not def, if and def, then your macro here, your text. The second line define the same text, and the end will be endif. And between this second line and endif, you place all the content of your header file. Okay. Now let's compile here, and we don't have any errors. Actually, it's working okay. We created and initialized successfully this student crawl, and then we are showing this data in the console screen. Okay. All right. Now I'll show you. Um, okay, you know that C programming language doesn't have a graphical interface, which is a standard. Okay, so we have to use third-party software whenever we have to create the graphic windows, just like this one with menus and reacting to mouse clicks and stuff. So here I am using a C++ code. C++ programming language is somehow related but also different to C programming language. But one of the common points is that it doesn't have a graphical standard user interface. So it also just uses the console window. So here I am using a graphical a GUI library which is FLTK of FLTK. And basically, I had to download it, and I was following some instruction from a book. And as you can see here, this is my project. It basically creates like a chart of the ages uh, of the population of Japan or something. Okay, as you can see here, this is a graphical interface. I mean, I am not showing in this black screen with console window, but also I have to tell you that in order to achieve this result and have this graphical window here, I had to use someone else's code. So it basically required the use of some header files and functions, just like we are doing in C with the standard uh, header files of its standard library. Okay, but here, as you can see, I have some header files. I will show you, and they have also the same way of working. They include some other header files. Sometimes they don't include the header guard, but some of they do, so I will show you here. So this is for you to be familiar with what we have already learned here. As you can see here, we have the header guard, and it ends in the endif directive. All right. So basically, this is something you can come across whenever you use graphical interfaces from C language or wherever else that you will have to, use uh, functions and header files, which predefined built-in functions. I just wanted to show you that. Okay, let me show you the last thing. This will be the last topic on header files. Um, I already show you that we are splitting the declarations of variables or functions in the .h file and the definitions in the in the .c file. Okay, so there's something else I want to show you. Here we have show student.h and show student.c. Let's say, for instance, that I have here in the .h file an integer called c. Okay, and now I'm going to initialize uh, c with the value of 5. Okay, and also I will include the same variable here, initialized to the same value. Basically, what I'm doing here is the definition of my variable, my integer variable c. Uh, but I am making a reference here, like the declaration or something, and I'm going to use it here in the main function. Okay, I'm going to print its value. Now let's hit compile and run. Okay, I will save changes first. Okay, now, and I will have an error which says first define here multiple definition of C. So basically, something else you have to know is that since the .c files are meant to um, contain the definitions of variables or functions, in this C file, I am allowed to do this because I'm initializing this to an initial value wherever it is. But in the .h file, I shouldn't be doing this because this is a definition. So if I instead would do the following, not initializing to, not initialize the variable to any value, but instead use the word extern, keyword extern, and just integer C, it will be taken as just a declaration. That means I am saying here, there is an integer called C, which is in another file. This is what extern means. This integer C is out of this scope. Where? Well, basically here, okay? But I am not doing any assignment or definition. I am just naming here an integer C, okay? So this is called declaration, but definition is when I give it a value, or for a function when I define its body. Okay, so now let's hit here compile, and now we have here 5 without any problems. Also, I could have done the following here. Don't Let's not use the word extern, but instead just keep in mind that I can't initialize here or assign it any value, because I need to do just declarations, and declarations means specifying the type and the name, okay, of the variable, but without using the initialization or anything else that implies a definition. Okay, so it will do the same without any errors, I guess. All right. So basically, this is why I wanted to show you. Don't do definitions in both the .h and .c file, but instead just definitions in the .c, and here just declarations, okay? Even when I use the word extern, if I initialize or assigned any variable some value, I am doing actually a definition. It means I am doing something that I am shouldn't be doing here in the reg file, but instead in the .c file. So that's it for header files. Thanks for your attention.